Hey, what's up, Moto Buddies? Mike here from Taco I want to give you an explainer video that talks about the Taco Snorkel system and the design criteria that I used when we came up with the concept, some of the things that we absolutely needed and wanted to integrate into the system, and then certain things that we absolutely did not want to carry over and integrate into our system. And so let's talk about the things first that were the no-go. These were items and data points that we explicitly and completely wanted to do away with because of the vulnerabilities and problems inherent to some of the original design components. And firstly, let's talk about the OEM original design fuel pump system. And so under no circumstances did we want to reuse any of this at all. And they're pretty apparent when you see this thing out of the tank. First of all, it's completely plastic. Everything about it is made out of plastic with a few rare exceptions of, say, the motor itself or the pressure regulator valve. And the reason we did not want to reuse this is because of all of the reasons why in the forums and in the groups you see people having issues. First and foremost probably is the fact that the upper cap is made out of plastic. And we deal with riders on the regular who sadly break off this outlet barb. It's vulnerable, it's plastic, and there's a lot of tears shed when this thing snaps off. Also, the bottom retainer clips, the motor retainer clips, there are three here, three tabs, and they're made out of plastic. And we have seen riders who will take, mainly on supercross, racetracks, the motocross, riders who will case a jump. And then as soon as the impact load of that strike is transmitted into the pump motor itself, the motor unit, these are a bunch of old units right here. And so this motor right here is pretty heavy. And so this will overcome the capture strength of the tabs down here on the bottom. And the motor has popped out of the bottom. And so this retainer down here snaps away, it falls apart, and then you're completely left stranded when that happens. And so we did not want to reuse that and expose our system to that vulnerability. What are some of the other things? Of course, all of this is plastic. And then you can't readily change the fuel pressure. So these are fuel pressure set. Stock fuel pressure on the unit is 48.6 psi to 52.9 psi. That's the OEM specification regulation pressure. And there are some instances where you may want to manipulate that pressure in race bikes, custom builds, custom tunes, and you cannot easily and readily change the fuel pressure, outlet pressure of this unit. The filter is good. The motor itself, we don't really have a problem with it. Durability has been pretty average. They're better than the older generation pump motors were, but we have seen some failures. Here's a bin. This is just a bunch of stuff that we've encountered in our work or customers have sent us when we try to autopsy out bad pumps and then trying to figure out the failure modes of some of those. So other things that we did not want to do, that we would not accept on our system, is drilling of any holes of any size, of any kind, in any location on the original tank itself. We did not want to subject our owners, our riders, our customers to leaks. We didn't want them to run the risk of drilling a hole in the wrong place, drilling too big of a hole. There are just too many risks for things going sideways and going wrong whenever you ask somebody to drill a hole in a tank. So we absolutely did not want that as part of the design criteria of our system. We didn't want any modifications or alterations of the tank in any way for the same reasons. The other reason too for the tank modifications and holes is there might be instances where you install a system and then for whatever reason you decide to go away from that system. Maybe you're going to sell the bike and you want to put it back to stock, or it just didn't perform the way you anticipated, and so you want to abandon it and just get rid of it, do away with it. So if you've got holes in your tank or modifications that you've made to the tank, you're not going to be able to do that. Also, you might want to transfer the system from tank to tank. So you may want to like sell a bike and then put it back to stock and then take that system and then send it over to another tank. And that's going to be made more difficult by those modifications and holes in the tank. So under no circumstances did we want any holes or modifications to the tanks. We also didn't want any modifications, alterations, or additions to the electrical system. We didn't want the added complexity. We didn't want added failure points. We didn't want to have the end users have to manipulate the electrical system or wiring or connectors in any way whatsoever. We did not want to increase the pumping outlet head pressure. So that what that means is like no uphill fuel. We didn't want to push fuel uphill. So for example, if this was remotely located somewhere else on the bike, maybe down in an auxiliary tank, in a secondary auxiliary tank, or like a skid plate tank, and then push fuel uphill towards the injector. We didn't want to subject the pump motor to additional pumping loads. And so that was part of the criteria. We also did not want to limit the use of our system to certain tanks. So for example, there might be certain aftermarket or OEM tanks that had design considerations that would prevent the installation of a system in a tank because of like a thin wall wing or some other criteria. We didn't want to have to, in our fitment category, we didn't want to have a bunch of inclusions and exclusions. We wanted only inclusions. We wanted only yes. Does it fit any tank? Yes. Does it fit any bike? Yes. Does it fit any aftermarket tank? Yes. We just wanted yes all the way down. And then we also didn't want any external hoses, any external connectors, outlets, fittings, failure points to be snag, damaged, or ripped off a crash, resulting in a DNF. We didn't want anything outside of the tank itself that could be a source of damage. We have, over the years, seen tons and tons of DNFs and other issues because of wires and hoses and other fuel system components outside of a tank. And so that was absolutely that would be a deal killer on our system if our design incorporated any of those whatsoever. So those were all hard no's for us. Now, what did we want our system to have? What were some of the things that we absolutely wanted to include and say yes to? So let me bring out our system now. So this is the Tacomoto double snorkel system. So what were some of the things that we absolutely needed and wanted to incorporate and said yes to? So first and foremost was it needed to be metal. Everything about the system needed to be metal and minimize plastic use as absolutely as much as possible. And so what we did is we incorporated a billet top cap and then a billet outlet port that is replaceable. In the rare instance that this would be damaged or broken off, we wanted the ability to change it out easily. And also something that you could get from a hardware store. So you could go to, if in a worst case scenario, if this broke off, you could go to any, this is NPT plumbing threads here with an outlet barb. So you could go to any hardware store anywhere in the world and buy a plumber's version of this and then get yourself back on the trail or on the road. And so that was a part of it. We did not want to add any additional moving parts to the system, no mechanical moving parts. And so just like the OEM system, so if I look at these side by side, and so we take a quick comparison view here, we have a pump motor, we have a pump motor. We have a fuel pressure regulator, fuel pressure regulator. That's it. Those are the only two physical moving parts. So we did not add a single mechanical moving, electrical, or mechanical moving part to our system. We did not want to add any electrical functionality. So we didn't want to add any draw, any demand, any new electrical components. And so we did not do that on our system. We didn't want to add any failure functionality points that would take out the operability of the original and the primary pump motor. So just like I said with those electrical considerations, we didn't want to add anything or do anything that would jeopardize in any way the operability and functionality of the primary pump motor. So any failure in any secondary or downstream system or component, we didn't want that to take out our motor. I think we already talked about the plastic, minimizing plastic. We did not want to, no holes, no drilling of any holes. And so we talked about that. We did not want to add any second, third, or fourth, or fifth, or sixth failure points. And we also wanted the fail-safe for the pump to go back to primary. So let me say it like this. If any of the added components that we have to the system were to fail, we wanted the system to then revert back to basically its primary function. So that would mean like if we had, so some of these things you can see are clearly add-ons. This is to the fuel sender unit. So there are components of our system that we could classify as add-ons. So what we demanded is that if any of those systems were to fail, it would not take out the pump, and then the pump would just continue to operate as a standard puller pump, pusher puller pump, and then run the bike. And so in no way would any of our ancillary systems cause the bike to not run. Now, a failure may cause the lift system. So this right here is basically our lift system. So we're pulling fuel from the two wings of the tank into the center cup where it's drawn into the pump and then pushed to the injector. And so if something in this system were to fail, then that just means that you would no longer be drawing from the lower wings, but it would absolutely not impact the operation of the pump motor itself. And so that set of absolute must design criteria really set the standard for the system. Let me see if there's anything else. We wanted this system to be installed in about 30 minutes. We didn't want this to take any longer. We set a time, maximum installation time of about 30 minutes. And we wanted you to be able to do that with ordinary skills. No special mechanical skills are needed, and no special tools, just ordinary backpack, DIY garage tools that everybody should have. We also wanted this to be fully serviceable and rebuildable in the field. Again, with simple, easy to obtain backpack tools, tools and supplies that you're probably going to have at a hardware store or a backpack anywhere in the developed or developing world. The system needed to have variable outlet pressure, and so we needed to have a PRV, a pressure regulator valve, that could be adjusted. And the reason we insisted on that is because there are, again, like I mentioned earlier, there are riders and race teams who may want to have a customized outlet port pressure. And so you needed to be able to easily and quickly vary the outlet pressure, and you can do that. That was part of the design criteria. We set these up for the KTM standard fuel pressure, and like I mentioned, that OEM book pressure is 48.6 to 52.9 psi. And when these go out the door, they all are set to about 50, 51 and a half, 52, somewhere around there, psi. And so they're well within the OEM specification range. And we wanted you to be able to adjust it and customize it if that was something that you wanted to do for your application. We also determined that we absolutely wanted it to be based on the 3,000 hour pump. This pump we have got thousands of these pump units out there, and we have only seen 2 warranty claims on these. One of them was because the pump had been exposed to water in a tank that had sat for a long time. And so we warrantied that for free, even though you could say that was user caused because of abuse, but we warrantied it anyway. And then the other one, we haven't cut it open to take it apart just yet, but I believe it's pretty much going to be for the same thing, just looking at it physically because of the corrosion. So we know why 2 of the thousands we've sent out have failed, and we just absolutely trust in its rock solid reliability. This pump is well known around the world as easily the most reliable and long lasting fuel pump motor for the KTM single cylinder bikes that there is. And so we for sure wanted to build our system around that pump motor for that exact reason. Our system needed to be self-priming. We didn't want to have any tricks or gimmicks with getting a prime going. And so that was part of it. The design also needed to be inspired by typical and classic technologies that were already easily and readily understood, maybe those used in aviation, racing, or other established fuel management systems in other industries. And so we wanted to base our tech around that so it would be easy to understood by anyone. We absolutely needed to pull fuel from both wings. And we had a couple of considerations and reasons why we wanted to do that. First and foremost is for racers. Now, let me say this. So this system was designed based on the input from my conversations over many, many months with dozens of people in the industry. I went out and reached out to racers, race teams, team owners, mechanics, factory mechanics, around the world travelers, people who ride their bikes over demanding conditions, BDRs. I talked to young riders, old riders. I wanted to really fully understand very broadly who the users were and what their needs were. And I compiled many, many notepads of lists of requests and advice and suggestions by all of these people. And so I basically shoved all of that into the meat grinder when we sat down to come up with our system. And having fuel drawn from both wings came from the desire of that, and the request of that came first and foremost from racers, rally racers. And the reason there is because if you're in a timed competitive rally situation, you're going to be both on-road and off-road. And you will have transit sections and liaison sections where you will run out of gas. And so what they did not want to have to do was to stop the bike, get off, and then tip over. So if we had a single pull from only one wing, then it would mean that as your fuel got lower and lower, you'd need to tip the bike over and then pull that fuel over to the other side. Now, that's what we've done on carbureted bikes forever when you have a fuel tap on the lower left wing. So that's not new or out of the ordinary for riders, but they didn't want to do that if they didn't have to, and so we could design around that. We could incorporate that. The other request came from older riders. So these would be vet riders, senior riders who are out doing BDRs and TATs and overland riding, and they will have their bikes very loaded down. So you've seen these where you have a 500 and it has Moscow bags, Moscow 80s on the back, and a tank bag, and sometimes you might have some a fender bag, and you have all of this kit and equipment on your bike. And so imagine you're a solo rider and you're out in the wilderness, and maybe you got a bad knee or a hurt elbow, or you've crashed, and so you have some physical impact there, some limitations. And now, because you're low on fuel, you have to tip the bike over. Maybe it's muddy, maybe you're on a hill, and so you have to tip the bike over to get the fuel from the right wing over to the left wing, and then to right the bike back up. And so that's just a big concern, a safety issue and a convenience issue for a lot of riders. And so that was something that we put into the mix as well. And so that was like a must-have as far as having a dual snorkel system pulling from both of the wings. Let's see what else. We also wanted the fuel sender light. So this is something. So the fuel sender that's the low light level. So it's right here on the original OEM unit. And so this light means as soon as the fuel drops below this point, then your low light will turn on the dash. And as you know, this, and I'll show you a cutaway tank here in a second, but this sits really high up in the tank. And so we wanted you to be able to set your light level wherever you wanted to. And that meant we needed to give you the ability to drop it down onto one of the hoses. We used the left because that's the lower of the two wings. And then we wanted you to have the ability to set and customize the level wherever it was that you wanted on the hose. And so that was part of our design criteria as well. So all of those needs, requests, wants, and hopes were all mashed together as part of the basis of design. How we started our design, we started there from that. Now, let me tell you about some of the designs that we rejected. So we started making these lists and we started rejecting certain design systems because they violated those absolute no-go breakpoints that I had established earlier. So what would cause an immediate rejection? A system that relied on the original OEM pump. And so one of the first ones that we started to conceptualize was to do a lift pump, a secondary lift pump, or a booster pump. And so what that would entail is you would have your primary pump here would stay in its place, but you would have a remote. So I'll bring in the cutaway here of a tank. So if we take a look at this cutaway, you'll see that the OEM pump design has the pump living in this little cavity up here at the top. And so you'd have the OEM pump that would sit here. And maybe just to give you a high-level understanding of how this works, this filter right here acts as a sponge. And so it sits down here in the bottom of this draw cup. And so if your fuel is higher than the draw cup, of course you're pulling fuel here in. But the problem happens as soon as the fuel drops below the frame rail, these two little cutouts on both sides for the frame rail. Now as the fuel drops lower, you're not going to be able to pick it up, and you will quickly drain all the fuel here in the center cup, and then you're out of gas. So the design concept of this is very straightforward and very simple. as the energy of the fuel tank is causing the fuel to splash up and down, that splash effect is causing the fuel droplets to then be absorbed into this. Imagine this is basically like a sponge. So that splash effect is what the fuel droplets then are absorbed into the sponge, and they're sort of passed through whatever's sucked up into the pump. That happens, and then this cavity just sort of fills. So this acts as a little bit like the Holley mat, the fuel mat product. Holley makes a really cool absorbent, super absorbent fuel mat product that does effectively the same thing. And so that's kind of what's going on here. So again, as long as you're bouncing around, no problem. Fuel's going up in there and it's being drawn into the pump and then to the injector. But like I said, you get on a flat, smooth road, and that goes away. So what the lift pump does is it would add a second pump. So you'd have a motor, you'd have something to push fuel, or a motor up here to push or pull fuel either way. And that fuel would then come up, be lifted up, and then transferred and dropped here inside of the center cup, so that this main motor, the OEM motor, can then pull it up into the injector. And so we rejected that because it violated a ton of our concept, our criteria. First of all, first and foremost, is it required the reuse of the new pump. So that was a hard no for us. It required drilling of holes into the tank so that you could mount the pump. That was a hard no. It required the addition of complex electrical components and connectors, and those violated our standards. It added extra load, electrical load. So you had an additional pump motor that was pulling power from the system. And so that was a hard no. It added third, fourth, fifth, and sixth failure points. So all of those reasons were no's. And then the failure, because the electrical tie-in, a failure of the secondary pump could impact the performance and then take out the use of the primary pump. So for all of those reasons, we rejected using a lift pump or a booster pump concept. We dismissed that. Then we came to another one where we would use a remote tank and a remote relocated fuel pump. And so what that would look like is where you would have the primary pump would stay in use, so you would still use this to push fuel to the injector. This would move away. So what you would do in that concept is you would blank off the hole that was left here when the pump is removed. And so you'd have to remotely locate this somewhere on the bike. And we had thought, well, why don't we make a fuel tank as part of a skid plate? So suppose you had a skid plate, and at the front of it, there are skid plates out there where you'll have a little tool compartment where you can store some tools with like a little door. And so we thought, well, we'll put a tube into that. And so, or we'll build a skid plate in such a way that this pump could be located into that reservoir. And then somehow we would need to get fuel out of this tank so that it could then be transferred down into that reservoir. And that would mean that you would have to drill a hole in the tank to put in some sort of outlet port or a petcock. And then from that, you would gravity feed the fuel down to the remote location where this was located. And so this could be located in a tank, like I said, as part of a skid plate. You could also have this be in a tank in a small, so that would be like a large tank. And the benefit of that is you would be adding extra fuel capacity to the system. So you might have a couple of liters, half a liter maybe, of extra fuel tank. So there'd be a bonus to that. So that seemed to be something worth considering. And then we thought, well, maybe that adds a lot of vulnerability. If you hit a rock and you damage that, it'd have to be made out of plastic or metal. Metal would be easier because it would not incur molding costs. Molding is incredibly expensive. And so we thought, well, we'll just have that welded up out of aluminum, but aluminum has the vulnerabilities of being damaged or torn, or a weld corner being cracked or broken if you hit a rock. So there were a lot of issues that arose there. And then we thought, well, maybe we'll skip that and we'll do something like mounting this in a small chamber. So we'll just make a little cylinder with a cap on the bottom and a small chamber, and then this thing can be remotely located. But for it to be usable, remember, one of our design criteria was that we needed to have this be universal fitment. So all of the brands, the 3 brands, KTM, GasGas, and Husqvarna. And then there are 2 different frame types. You have PDS bike, which has the shock that actuates against the swing arm itself. And then you have a linkage, where the linkage has a articulated section in the swing arm, in the cavity, in the whole of the swing arm in the rear. And then the shock lives there. And then you have a 2-stroke and a 4-stroke, and they have different physical characteristics and considerations. And so all of those variables impacted the placement of where this secondary, so again, this little sleeve, a little cup or bucket that you would put this in. Where would you mount that on all those different types of bikes and different configurations? There was no one answer, because what might work on a PDS bike won't work on a linkage bike, and what might work on a linkage bike on a 4-stroke wouldn't work on a 2-stroke. And there were just so many variables that we and then the primary other thing about reusing this plastic OEM pump. So we just dismissed all of those options out of hand. And so to summarize, they rely on the OEM pump. They expose the pump to environmental damage. So in both of those scenarios, in all those scenarios, this unit, this top cap, would be sitting exposed. It'd be exposed to sunlight, to UV sunlight. It would be exposed to rocks, rock damage, flying shrapnel damage. It is 100% the case that when you are in a racing situation, the bike in front of you is throwing rock shrapnel at you, high-speed projectile rocks, machine gun bullets, they are flying at you. And so we could easily envision a situation where a flying rock off the back tire of a bike in front of you would hit this in whatever orientation we mounted this and break it. And we thought, well, we could put some little shield or a cover over it, but you still end up, you're just sort of band-aiding around the reality that you have this plastic pump, that you're reusing it. So we dismissed it for that. What else? Another thing that would happen is this pump motor would be rigid mounted on the bike. So it would be in that little capture can, in a fuel pump, or in whatever contraption we came up with, we devised to mount this. We already talked about the fact that the bottom of this fuel pump is vulnerable to shock loading and having the bottom of that pop away and release itself. We've seen it. It's happened. And that's even when it's mounted in a plastic tank, which has some yield. This tank, under shock loading, the fuel can compress the bottom, the wings can sort of push out, the top can compress, and so you figure, and this is mounted, the tank itself is mounted on a little rubber pad along the frame. So you figure there is some yield factor to the fact that you have a plastic tank to absorb a certain amount of that shock loading, and yet the pump still drops out of the bottom. And so we just were envisioning, now you're going to hard mount this into some aluminum capture device, whether it's back at the swing arm or up at the front end for like that skid plate. Either way, it is hard and rigid mounted. And so if you took a rock hit or some sort of hit, imagine casing a jump with, or a rock, imagine coming down on a tree log or a rock, you're in a hard enduro situation, and again, this is hard mounted on the bike, and all that shock loading popping the bottom of this out. So that was just an absolute hard no on for the design concept of that. These also required pushing fuel uphill. Remember, I said that we did not want to put any extra demand load, pumping load on the motor itself. And so if this was located really low on the bike and the injector's up here, and now this is down in the skid plate, you're pushing fuel uphill against gravity. And so that's increasing demand load on the motor and the impeller. And so that was a no-go for us. Also, again, if you're hard mounting this on the bike, you just have all those vibrations. At least when you have it mounted here, you have some damping effect, like I talked about, because of the rubber frame rail, and then the fact that the tank itself is plastic and can yield somewhat. You also have the fuel that acts as sort of a damping fluid within the tank itself. And so there's a benefit to having it remain located in the tank. There are upsides to that. Let's see, we did not want to add that secondary tank for all those leak possibilities like I talked about. It also meant that you would have to add additional hose links, additional clamps. That hose would be exposed to sticks, rocks, crash damage, hard enduro situations, and then you'd have to extend the wiring. And those were all hard-nosed for us as part of our design criteria. And it just added complexity and second failure points, third, fourth, fifth, and sixth and seventh failure points. So remote mounting in a situation like that was a no-go for us. Another one of the systems was to use the original motor, but then have a straw that would, so you have a scenario, this is the third scenario, so you'd have the motor, the OEM motor here, and then you would remove the bottom filter cap and you would install some sort of adapter that would send a single straw down into the bottom wing of the tank. And so some of the problems that you had with that is, first of all, you reused the motor, and we've already talked about that was a no-go for us. Then you had this straw. Now this vane type impeller motor is not a suction motor. It does not pull air. It's a fluid impeller. It is no different than if you've ever removed the water pump on a car and you've just seen that it has like fan blades. The fan blades or a boat propeller, that's exactly the design. Well, there's some slight variations with the construction of it and the design of it, but that's the same idea. It's a pusher. It's an impeller that pushes a fluid once it's in contact with that fluid, and then it pushes it out of the cavity. So it pushes it out the top and to the injector. So it will not push air. It will only push fluid. And so if you have this in the tank and you've lost prime, and you will lose prime every time you shut this motor off, the fluid will drop down and it will like back siphon down and you'll air gap the hose. You cannot, this impeller will not and cannot air gap itself. It cannot pull that air to get access to the fluid. Fluid must remain in contact with this at all times. And so that's not possible with a single straw system. And so because of that, because you air gap it, because it requires special techniques to overcome the air gap and the priming issue, then you needed to understand and like practice special tricks. And so all of those were deal killers for us for all those reasons that we talked about. So that's three types of systems that we evaluated and then rejected. And then a fourth one, happily IMS came along and solved that problem. And so the fourth would be to use the original old school design fuel pump system. And so for those of us who have been riding Austrian bikes for a long time, we've seen this pump. We've had this pump all the way from, on the enduro bikes, 2012 all the way to 2023. And then in the off-road bikes, the competition race bikes, 2011 to 22.5 with the factory edition is what they call it. So this pump system has been tried and true for many, many, many years. And it has some advantages and disadvantages. One of the advantages is it puts the pump motor down here in the lower left wing, and it's self-priming, and that fuel, if you have any fuel at all in the tank, it's going to be present to the bottom of the pump motor, and then it will push up. So this is a pusher type, right? So the fuel is drawn into the bottom and then it pushes out, and then it goes up here to the regulator where it's pressure regulated, it's filtered, and then it comes back down, and the outlet here, the small one on the right, this is the outlet that goes to the injector. So the system has been proven as far as its the fitness of it. Now Tacomoto has come along and we have many upgrades. We have filter upgrades, we have pressure regulators, and we have pump motors. So there's a lot of upgrades that you can do to this to make it more reliable and make it super bulletproof. And that system, our system and the modifications we've done there are bikes right now that have gone many thousands of miles that are going around the world. This pump system itself with our modifications have won the Baja 1000. They race in every race series around the world. We get emails and we hear from riders who have this system in every race discipline and every type of ride discipline all around the world. And like I said, we've only had 2 motor failures in a few thousand, maybe 3,000 that we've sold. So the reliability of this is just so well proven and established. So using this system in a fuel tank does make sense. So the clever people at IMS came along and they designed their tank that has the right shape of an outlet port so you can feed this in. So this is the new gen tank see here that there's this sort of blank off area where your round pump would go. So they make every tank they have that has this ability comes in 2 flavors. You can get like flavor A, which is the hole here in the middle, and then this would be blanked off because you would install a round style, whether you use ours or the OEM one, but you'd use a round style pump motor that would go here into the cavity. Or you could get in the B configuration, which is, so it's blanked off here, and then you'll have this oval opening here, which allows you to install, you'll feed that in. So you'll install the old style pump system into the tank, and there's the 2 holes here, and they're designed in. So when this tank is made, it has the 2 holes here, and you convert over your pump assembly, your tank and your pump assembly to this architecture. So what are some of the reasons why we had thought about this and IMS executed on it? Now, we are not a tank manufacturer, and so there's no way I could do this. And so we needed to rely on the aftermarket, and IMS came along and did that. So it requires this old pump system, and it pulls fuel from only one wing. So some of the reasons why we couldn't proceed with this system, in spite of the fact that it does have some advantages, a disadvantage as far as our criteria was concerned is it required you'd pull only from one wing. And so that was one of our negatives. But in terms of positives, this was the best of the systems we evaluated up to that point. So we rejected 3 of the other ones for all of those obvious reasons. But this one had some strong positives. You had a reliable pump system that you could use. It's guaranteed in a known entity, and those are the upsides. So what are some of the downsides? It requires you to invest in an all-new tank. So you cannot use this on an OEM tank. So if you're a rider who wanted to maintain use of the OEM tank, this is unavailable to you. You have to buy an aftermarket tank, and so these are not cheap. I think they're $475. And then this unit itself, you have to go out and source this. And so there are aftermarket versions. We sell a version of this exact unit that's fully hardened off with all of our upgrades and features. And I think by the time you're all in, it sits at like $600. The OEM version of this, I think, is 500 something bucks. And then you're going to need the hoses and the adapters and the connectors and all of the things that go along with putting this system in a tank. And you're easily over $1,000 by the time you get this on your bike. You're like 11 or 1,200 bucks by the time this is installed. So there was a huge cost consideration as far as this goes, and you're limited to the, they don't have this for all tanks, for all sizes, IMS. There's limited capacity of this for the gas bikes. And again, like I said, we wanted to be able to do all bikes and all brands. So this system was the better, so now this is system number 4, option number 4. This is the best of the 4 options so far, but it had limitations that did not tick all our boxes. And so this system, it is what it is, and it's a great one and a good solution for many options or for many riders. It just wasn't our solution. So now we come back full circle to our system, and I've already talked about some of the reasons why this was the design that we settled on, and the reasons why we went with the choices that we made. And here it is. It's amazing. We have 200 plus of these out there in the world, and so far the reviews have been excellent. People have been draining their tanks all the way down to complete empty. We've got riders who have completely done away with carrying extra fuel. Their range anxiety is gone. Just over and over, I hear from riders who are so pleased and happy with this, and we continue to make more and send more out all over the world. And so what are the downsides to our system? Let's be real. There's no such thing as a solution that is only upsides. There are some downsides, and so let's look at what ours might be. Your magnets here attached to the outside, so we hold our sinkers to the tank with magnets. And so this uses 3M I think it's called VBM. It's really aggressive, VHB, super good, super aggressive adhesive tape. And so that sticks to the bottom and the outside of the tank. Well, this tape is not going to last forever. We've used it for years on tanks in testing, especially here in harsh conditions in Las Vegas. And you could end up in a scenario where this tape over time will weaken and it could fall off. The magnet could fall off. So in a worst case scenario, the sinker is no longer retained, but gravity and then the flex of the hose will basically, and we've done this, we've intentionally run these on bikes where we just drop this in the tank and we don't bother to put the magnet on, and there's no issue. But I'm just giving you the heads up. This tape could come loose. It could fall off. You could have a crash where like a stick or a rock happens to get at it just at the right angle at the right spot and then rip it off. We sell these. We can send these out to you, and to fix it, you just reattach it. Simple as that. But you could lose one of those. You could have one of these sinkers get clogged, and so you'd only be pulling from one side as opposed to the other side. You would be able to clean this though. These are fully serviceable, fully rebuildable. This hose is Tygon. This is made by Globe Saint. What is the name of this company? Global Saint, I forget. But this hose is rated for its use. However, it will get stiff over the years. After consulting with them and talking to their engineering staff and really trying to dive as deep as I can into the world of aviation and other motorsports industries that use this exact product, the general consensus is that this hose has a service life of about 5 years in a tank. And that doesn't mean that it's gonna like dissolve in 5 years. It means that it will have a level of flexibility for 5 years. And beyond that, and different fuels, look, that's just the general consensus. Now, results will vary because different fuel types will cause different aging vectors in this hose. It may last longer. It may get stiffer sooner. We just don't know. But what we can tell you is that we can sell you more hose, or you could get more hose from the hardware store. There is nothing special or unique about this hose. It's available in all kinds of places. And so if in a few years when you go to service your system and you pull it out of the tank, if this hose is stiff and inflexible, it can be replaced, no problem, either through us or some other source. Another thing that could happen is you have there is a flow port here that pulls the fuel up into the draw. This is the outlet hose that goes into the cup. Now the fuel that comes up in here does not go through the flow port where it necks down. And so unfiltered fuel can come up here. So there's no worry about a clog in the flow port because the pressurized fuel that could present a clog risk is coming out of the filter, and it's filtered. So, or it's coming out of the pump that has already been filtered. So to say this another way, the fuel that could pose a risk of clogging the port comes through the filter, through the motor, and then out. And so there's no risk of it, in practical terms, there's no risk of it, of the flow port here clogging up from debris because of the filter. But I just let you know that that is a potential risk. And so if that were to happen, based on our design criteria, this would not cause the primary motor to lose its functionality. It just means that you wouldn't be drawing from the dual wings. This would effectively be knocked out. You don't have the draw, but in no way will it affect the operation of the pump motor itself. This will fully and completely continue to operate. So there's that. What else? I'm just trying to think of what some of those issues could be for full transparency. So our filter is a little smaller than the OEM filter. There's a little bit less surface area. And so we're recommending a 2-year replacement service interval, and you can get these replacement filter pads from us. This is the same micron rating as the OEM filter, so we're doing the exact same job as the OEM pad. Just a tiny bit less surface area, but for super cheap, we can sell you a new one of these. And a rebuild kit will have any of the O-rings and any of the serviceable parts in the kit. It will come with that as well as the filter itself, so it's completely rebuildable. We talked about the potential risk of the outlet port barb, and I think we were pretty clear about that. If you had a problem with the electrical connector, this is a replaceable part and easy to service and we can get you another one of these, no problem. You have these exposed terminals right here. Somebody in in a comment once said, well, there is a risk of water sitting on top of this. And to that, we make the comment that the battery sits there with exposed terminals with the risk of water. 12 volts DC operates in a different fundamental than AC current. And so for those of us who understand that, we're not concerned in the least. Somebody said, well, these are naked and exposed. And so what happens on this system is when your seat is on, your seat covers this. And so you're not going to have tools or anything metal that's going to be right there in the area to cause any issue with that. So there's just no real concern about that. Somebody had also said that somebody could come up with you could cover this with a piece of tape, or you could 3D print a little cap that would sit over that. I don't know that we're going to pursue any of that, but if your level of OCD requires you to do something about that, a piece of tape over the top of that solves it. We don't do anything about it, but I'll leave it up to you. There is an O-ring here. That is a potential failure point. And like I said, a rebuild kit allows you to service. It'll have every one of the O-rings on the entire system to fully and completely rebuild it. How often should that happen? We think you should do the filter in about 2 years, and we think that you should do the entire system in about 5 years. If you wanted to do it sooner, preventatively, by all means, of course, you could do that. And you could go longer as well, but that's what we're recommending. So looking at my notes here, the other downside that I hear from people is cost. This is, at the time of making this video, it is $689 retail. Is that a lot? I don't know. You're going to be over $1,000, $1,200 for the IMS solution. You'll be less if there are other competing products out there that use some of those design standards that we had rejected. Those products may be out there. They may be on the market, and they may be at a lesser cost than this. Just understand, we designed this as a absolute zero compromise system, and so the cost is what it is. And I like to operate on a buy once, cry once mindset. There are lots of things that I purchase for myself that I use on my bikes, or I use in business or in life, and I'm continually looking for the best in class, and almost always those are the most expensive of the products available. And so that buy once, cry once mindset is something I use when I make those decisions. So those, I think, as honest and as transparent as I can be, those are the full ins and outs of our system, its advantages, disadvantages, as well as advantages and disadvantages of other scenarios, other types of technologies that could be used to solve the problem, the fuel pull-up problem. Maybe just as I finalize out here, this system has been rigorously tested. We have used this ourselves in very demanding situations through Baja. I've got lots and lots and lots of miles on this in Baja, Mexico, Colorado, Idaho, Nevada, the deserts of the Southwest. We have had test riders out there beating this up. This has been used in race conditions. Also, this system was tested by KTM North America. The mechanics and test riders of KTM North America have this system, and led by Quinn Cody, our buddy over there, he has given this a big thumbs up endorsement. And so while I can't put words in his mouth and claim that there is an official endorsement by KTM North America or Quinn, I can tell you that those are the results of their testing was positive, and he verbally said, effectively 2 thumbs up for it. So without, again, overstating the claim, that's where we're at as far as the testing from that group. And again, with testing of lots and lots and lots of other really highly qualified people in the industry, engineers and other professionals have signed off on this and really given us their vote of approval and 2 thumbs up as well. So if you have any comments or thoughts or suggestions about this, please let us know. We are very transparent. We leave our comments on. We don't delete comments. We listen to you, and we want to hear from you. So let us know down below if you have any thoughts about this in any way. We'd love to hear that. If you would like to see any of these parts or see the system, we display it out at all the Dusty Lizard events that we go to, and we do more events, and we try to bring this out there so people can see it and understand how it works and answer any questions we can. So I think that's a wrap. Thanks for watching. Like, subscribe, go out, get some adventure.